Hello friends, welcome to Wiki Lectures. In this lecture, we are discussing the Karnataka Set 2020 question paper, question number 61 to 80.
So to get the output 1 from the given circuit, ABC should be. Now in this question, please don't go with putting selecting each one option one by one. First of all, what you have to do is find out what is Y. So this is C and output will be C dot C bar. Using De Morgan's theorem, we get C bar plus C bar, that is nothing but C bar. Now this is A and B, so product will be AB. Now this is again an AND gate, so this is NAND gate, this is AND gate. Again you have AND gate here, so Y will be equal to product of this C bar and AB, so ABC bar. Now if ABC bar must be equal to 1, A must be equal to 1, B must be equal to 1 and C equal to 0. Only then this will be equal to 1. So what is the option? Option B. Question number 62. A weighted resistor network is used as a 4-bit digital to analog converter. If the current through the LSB resistor is 10 microampere, what is the maximum current through MSB? The LSB is least significant bit and the MSB is most significant bit. Okay, now this is 4-bit digital to analog converter. That means there are 4 digits, bits. The last one, this is the least significant bit and this is the most significant bit. Okay, and the numbers are given for the power as 0, 1, 2 and 3, and the corresponding values are 1 into 2 to the power 0, that is 1, 1 into 2 to the power 1, that is 2, 1 into 2 to the power 2, which is 4, 1 into 2 to the power 3, which is 8. Now the question given is, through this least significant bit, that is 1, there is a passage of current of 10 microampere. Then what will be the current through 8, that is the most significant bit? So you can write for 1 is to 10 microampere, then what is 8 is to, now 1 by 8 is equal to 10 divided by x. This is what we have to find out, that is x is equal to 80 microampere. That means the current passing through the most significant bit, that is this bit resistor, is 80 microampere, which is nothing but our option D. A mod 12 counter whose output is DCBA is to be made using a ripple counter. The decoding gate for this will have the input as which of the following options? Now from the question, it is mod 12 counter, and after the 12th cycle or after the 12 inputs, you get the output as DCBA, which is nothing but 1 1 1 1. Okay, because nothing is being negated. Now the 12th output in general is 1100. How do you get that 12th output? 12 in binary number is 1100. This is 8, this is 4, this is 2, this is 1. Okay, so 8 and 4 are there and 2 and 1 is not there, so it will add up to 12. So this is 12th count is 1100, which means your 1100 should be the output as DCBA, which should be equal to 1111. In that case, this 0 should go to 1 and this particular 0 should go to 1. That means the last two terms, that means we have 1100, it should be written as 1111, which means this should be negated. It should be given a bar, and if you give bar to DCBA according to this input, we will get D, C, B bar. Why B bar? Because it is 0 bar, and again A bar. So this is the last output in the mod 12 counter, okay, which will be the input. So option is option C. Most metals used for temperature measurement in the form of resistance thermometer. Now this is a kind of thermometer which is used for measuring the temperature with the help of resistance in a particular metal. The variation of the resistance in the metal is used for temperature measurement. Now this electrical resistance, these metals such as platinum, nickel or copper, these are the metals that are used for resistance thermometer. Which are the metals used? Platinum, nickel or copper. And the peculiarity of this material or these metals are they linearly depend on temperature. Now according to the question, the option is positive temperature coefficient of resistance. This resistance as a function of temperature is given by RT is equal to R naught into 1 plus alpha T plus beta T square plus gamma T cube, etc. Now this linearly depend on temperature. Now R naught is resistance at 0 degrees Celsius and RT is the resistance at T. Question number 65. Which of the following is not part of lock-in amplifier? Now what is lock-in amplifier is, these are used to detect and measure very small AC voltages. So detection of signal is required. So there is a phase sensitive detector. This is a technique to single out the component of signal at a specific frequency and phase. Okay, so there is a phase sensitive detector, and it is to detect very small AC signal. So there must be a requirement of amplifiers as well as integrators. So small signal amplifier is there, integrator is there. Only thing which is not present in the lock-in amplifier is differentiator. Differentiator is not present in the lock-in amplifier. So your correct option is option C. Question number 66. Heterojunction devices are made up of GaAs, that is gallium arsenic, as well as aluminum, gallium, arsenic, because they have now the uh, about the band gap, they have unequal band gaps. That means they have different band gap, and their structures are given here. The structures are almost similar, so they have different band gaps but similar crystal structure. Okay, so the option is option A. This both heterojunction devices made up of gallium arsenic and aluminum gallium arsenic has got different band gap but similar crystal structure. Question number 67. The output of driver is 75 ohm. The maximum power is transferred when? Now there is a law of the network, that is electronics law. That means if you have a network here and this network is feeding some voltage to uh, the load RL, and here you have the resistance R. That means the network has the total resistance equal to R and the load as RL. Then the maximum power will be transferred when when R is equal to RL. Okay, now this is the law. Now according to the option, when it is connected to a load of 75 ohm, okay, this is well and good, by using 75 ohm cable, that is not relevant. Okay, so that is one part. That means the driver has 75 ohm and the load is 75. Okay, now in the second part, it is connected to load of 75 ohm, so well and good, by single wires. So let us look into the third option. It is connected to a load of 75 by 50 ohm cable. uh, this is not fair because it will have its own resistance. Now it is connected to a load of 50 ohm, so this is absolutely not correct. So the uh, options which can be possible are 1, 2, and 3 is not possible, and 4 is as well not possible. So options 1 and 2 are correct. So the option according to the codes, the option D is the correct answer. That is 1 and 2 are correct and 3 and 4 are wrong. The ground state of cesium atom. So ground state means they are asking the spectral term. Now the atomic number is 55. That means number of protons and number of electrons equal to 55. Ground state. Now this is the electronic configuration of cesium atom, and the last electron is in s orbit. So you have in s orbit one electron. Corresponding to this s orbit, we can write the spin, that is equal to half. L value of s momentum is 0. J is equal to L plus half to L plus half minus half, that's equal to half. Then you can write the spectral term L J 2s plus 1. So here you have to write the J value. So L is nothing but 0, which means yes. J value is equal to half. S 2s plus 1 is nothing but 2 into half plus 1, that is nothing but 2. So 2s half is the ground state term. So your option is B. To demonstrate Stark effect experimentally in one electron atoms, nothing but hydrogen atom, or you can say helium plus. Okay, then what is the value of electric field required? Now you know Stark effect is nothing but just analogous to Zeeman effect. Zeeman effect. In Zeeman effect, you are using magnetic field. In Stark effect, it is splitting is due to electric field. So very high electric field is required. High electric field is required to split the levels, energy levels. So the value is 10 to the power 5 volt per centimeter. Value of electric field required. Question number 70. In a normal Zeeman effect, the middle spectral line is now the Zeeman shift, that means the shift in the frequency is given by this particular term, that is EB divided by 4 pi ME into C, where B is the magnetic field, E is the charge of electron, M is the mass of the electron, and C the speed of light. Now here the shift in the spectral line is given by nu naught is the middle spectral line, that is middle spectral line. Now this is left and this is right. Okay, now nu naught minus EB divided by 4 pi MEC, this is circular polarized. Okay, this is also circular polarized. Left and right, left circular polarized and right circular polarized, and nu naught is not polarized, this is not polarized. Okay, these both are right and left are circularly polarized, and this is also circular polarized, and the middle one is not polarized, so your option is option C. Question number 71. One of the following elements shows doublet spectral feature like alkalis. Now alkalis are group 1 and 2. Now from the options given are boron, aluminum, barium and oxygen, and their corresponding atomic numbers are given in the second column, and the single ionization will give rise to the this many number of electrons, and by comparing their groups only barium will fall in the group 1 or 2, which makes it have a doublet spectral feature similar to alkalis. So the barium is the correct option, that is singly ionized barium, the option C. A proton having a magnetogyric ratio is same as gyromagnetic ratio gamma of 3 into 10 to the power 8 radians per Tesla second, is processing in a magnetic field strength of 5 Tesla. That means external magnetic field B naught is equal to 5. Its NMR frequency is nearly, or it can be also asked emitted frequency. Emitted frequency also can be asked, or NMR frequency. So NMR frequency is given by nu equal to gamma times B naught by 2 pi, where gamma is gyromagnetic ratio, B naught is external magnetic field. Just substitute the value. Nu is equal to gamma is nothing but 3 into 10 to the power 8 radians per Tesla second into B naught, magnetic field is 5 Tesla, divided by 1 by 2 pi radians. Now that is equal to Tesla gets cancelled, radians and 2 pi goes here, radians. So here what is left is 3 into 10 to the power 8 into 5 divided by 2 pi is nothing but 6.28 into 1 by second or hertz. So this is equal to 150 by 6.28 into 10 to the power 8 hertz. So what is that? You will get a value around 2.39 into 10 to the power 8 hertz. So that's equal to, nearly equal to, you can write 240 megahertz, which is nearly equal to this 250 megahertz. So this is the formula. Please remember this formula from this question. Nu is equal to gamma B naught by 2 pi. Gamma is ferromagnetic ratio, B naught is the external magnetic field. Question number 73. In Born-Oppenheimer approximation, the following assumption is made. Now, what is this Born-Oppenheimer approximation? This Born-Oppenheimer approximation is used to describe the quantum state of the molecule. Quantum state of the molecule. Okay. Now, to describe the quantum state, we have to assume that the electronic motion and the nuclear motion has to be separated. To describe, we have to separate both the electronic motion and the nuclear motion. And to separate this, we have to consider nucleus as stationary. So the option that we have here is the option D, that means nuclei remain stationary in relation to the fast moving electrons. This is a molecule, this is atom A and the atom B. In this, we are assuming this nucleus as stationary, while this electrons, which is given in the color red, keeps moving. Question number 74. For the molecules, the state sigma 1 refers to. Now, the sigma 1 is nothing but 2j plus 1 sigma. Okay. Now, what is this j? J is the total angular momentum. Total angular momentum. Quantum number. Okay, momentum, quantum. Okay, you can write total angular momentum. Now, when 2j plus 1 is equal to 1, that means here 1 is equal to 2j plus 1. So 2j plus 1 equal to 1 implies 2j is equal to 0 and j equal to 0. And what is j? J is nothing but L plus S. Now L plus S is equal to 0. This implies L equal to 0 and S equal to 0. L equal to 0 is orbital angular momentum. Orbital angular momentum is 0 and S equal to 0 means spin angular momentum equal to 0. So both orbital angular momentum and spin angular momentum are separately equal to 0. So the option is C, that is both spin and orbital angular momentum of the electrons are 0. If the average separation between adjacent lines of rotational in IR spectrum of carbon monoxide molecule is 3.844 centimeter inverse, then what is the rotational constant? That is the question. Now the separation f of j, that means f is a function of j, it is written as b into j plus 1. Now where b is called rotational constant, rotational constant. Now this f of j value is given as 3.844. Okay, this is equal to b into, now what should be the j value? J value, delta j, we have written it as plus or minus 1. That is the selection rule. This is called selection rule. Then j, if j equal to 1, j plus 1 equal to 2. So b into j plus 1 is equal to 1 into 1 plus 1, that is 2. So then what is b equal to? B is equal to 3.844 centimeter inverse divided by 2, that is equal to 1.922 centimeter inverse. So your option A. Now if delta j is plus 1, this is called absorption. Delta G minus 1, emission. Okay. Question number 76. For the vibrational transition 1 from 0, if the band is referred to as fundamental, then the transition to 2 from 0, the band is called what? Now let us see. 0 to 1, this is called fundamental band, and 0 to any other level greater than 1 are called overtones, and from 1 to any other level greater than 1 are called hot transition or hot bands. Now in this figure, 0 to 1 is the fundamental band, and from all other transition from 0 to 2, this is called first overtone. 0 to 3 is called second overtone, and from 0 to 4 is called the third overtone. Now from 1 to 2, that is our third criteria, these are called hot bands. 1 to 2, 1 to 3 and 1 to 4, these are hot bands or hot transitions. So from in the question they are asking from 0 to 2. So from 0 to 2 is the first overtone. So the answer is option B, first overtone. The ratio of the spontaneous emission process probability to the stimulated emission process probability. These are Einstein's coefficients. Einstein coefficients, that is the spontaneous emission process probability is A, and the stimulated emission process probability is B, and the ratio of A by B is equal to 8 pi h nu cube divided by c cube. Or if you want to write in terms of the angular frequency, you would get h omega cube divided by pi square c cube. So in this you can understand that the ratio A by B is proportional to the transition probability cube. So from the option, it is the option D, that is the ratio of A by B is proportional to the cube of the transition frequency. For an electron configuration in which there is one s electron and one d electron, the resultant spectral terms are. Now, according to the question, you have one electron in s orbit and another electron in d orbit. So here you have another electron. So this is s and this is d. Now the total angular momentum L, for s you have 0, for d you have 2. S spin is equal to half. Here also you have half because one electron is present. Total L equal to 0 plus 2, that is 2. Total S is equal to half plus half, that is equal to 1. Now J value is from L minus S to L plus S, which is equal to L minus S is nothing but 1 to L plus S is 3. So J values are 1, 2 and 3. Now how will you write your spectral term? Spectral term is represented by L J 2s plus 1. This 2s plus 1 represent SS coupling, L represent LL coupling, and this J represent LS coupling. Now L value is equal to, total L value equal to 2, S value equal to 1. So L value equal to 2 represent which state? 2 represent D state, D. Then J values are 1, 2 and 3. 2s plus 1, S is equal to 1, 2s plus 1 equal to 3. So spectral terms are either D13, D23 and D33. These are the spectral terms. In a BCC lattice with lattice constant A, the body centered position from the origin is at a distance of, body centered position of atom or molecule, anything. Okay. Now this is the BCC structure. You have lattice constant A, this is also A, this length is also A. So this will be root 2 times A using Pythagoras theorem. So considering another right angle triangle here, this will be right angle. So here also this is EA. So root 2A, root A. So hypotenuse will be root 3A. Now what is the question? Question is from the origin. Let us take this as the origin. From the origin, the distance of this atom. So there will be an atom at the center. So from to the center, what is the distance? This is what is asked. Okay. So what is that? This will be half of that. So root 3 by 2 times A is your answer. So root 3 by 2 A. Option C. In a cubic crystal, the interplanar spacing of HKL plane is represented by DHKL. Which of the following is true? Now before going into the option, let us write down the formula. DHKL, the distance is given by A divided by under root H square plus K square plus L square. Now let us write down one by one. A divided by root 3 and A divided by root 1. It is said it is greater. So this one is greater. So this is false. So A divided by root 2 greater than A divided by root 3. So this is true. So you need not check the remaining options. Option B is correct. But still let us check. A divided by root 3 less than A divided by root 5. a divided by root 4 greater than a divided by root 3. So here this is greater, so this is also false. Here this is greater, so this is also false. So option B.